Hi friends, today we have to see the small signal analysis and the numericals and the problems based on small signals. In the last time we discussed about DC analysis and AC analysis. In the DC analysis we have to turn off all AC sources and capacitor as well. In the AC analysis we have to turn off all DC sources connected in the circuit. If you will see over here in this slide, this portion relates to the DC analysis of the circuit and this portion related to the AC analysis of the circuit. Or in other words, I can say this is the AC analysis circuit, this is the DC analysis circuit. Is it okay? Now we'll take some problems based on this. They will ask something, we have to find something. So in the problems, I'll show you how we have to proceed in such type of problems, right? But before that, let me finish this theory part. We have completed till now in the last slide, I think, in the last video. So for AC equivalent circuit, reduce DC voltage sources to 0 and open current sources and short all capacitors. This circuit is used to calculate AC currents and voltages as shown in the figure. I think this part is over. Now let's come to the the total current in any branch is the sum of DC and AC, obviously, right? But at the output we are having voltage due to AC only. At the input we are having only AC. In between, in the entire circuit, we have AC as well as DC. This is the theory behind this, right? So in the entire circuit, or the total current in any branch is the sum of DC and AC currents through that branch. The total voltage across any branch is the sum of the DC voltage and AC voltage across that branch. I hope this point is clear to you, right? So now we'll take some problems. So friends, we'll see some problem, but before that we have to discuss. See one thing. In this circuit I'm talking about, this is the circuit parameter, this is the circuit parameters, outside R1, R2 and all about this, input portion, output portion. We are having equivalent of this device also, the BJT equivalent also. We need to draw, if you are going to calculate anything in the circuit, voltage or current or power, whatever, you need to remove this BJT part or not, tell me. If you want to solve some circuit, you need some current element, some inductor, some capacitor kind of thing, so you can, or some dependent or independent sources, so you can easily evaluate whatever they're asking. If they're asking for the current, you can calculate. If they're asking for the voltage, you can calculate. So we have to remove this part or not. So now I'm showing you, we are having equivalent of transistor also. So whenever we are solving the circuits by applying AC and DC analysis into it, we have to replace the transistor also by its equivalent model in terms of resistance and dependent source kind of thing. So we'll see that equivalent part, and then we'll switch to the problem portion, right? So I'm taking, see, this is the transistor symbol, emitter portion, collector portion, and well-known base portion. Is it okay? I have the equivalent circuit of this. If this emitter is common between these two, I have the equivalent circuit. See, from B to E or E to B, I can say, we encountered with some resistor over here. Will there any resistance or not? Yes, there will be resistance. So from B, if this is B, this is collector and this is emitter, grounded emitter, okay? This is grounded emitter. So from B to E, I phased R pi. Over here. This R pi is the resistance between base and emitter. Is it okay? So if the current in the base is IB, So this IB current is coming into the emitter. So if this current is outgoing, so definitely IB will be incoming current into the BJT and IC also will be incoming current. So you can see IB is coming from base to emitter. Now you replace the base to emitter portion with the R pi. Is it okay? And this R pi is nothing but beta RE. This R pi sometimes you can written over here. This is beta RE. Now what is RE? We'll discuss about that. Come to the collector part. In the collector part, see the current is incoming or outgoing. There is incoming current and beta times of IB. Incoming current. Current is coming to the, current is coming into the emitter. Is it okay? And this collector current, this is collector current or not? And collector current in terms of I beta or IB is nothing but beta IB. This is equivalent circuit of this type of combination, BJT combination. Okay. If the emitter is common, so I have to take common emitter in both these two terminals. Is it okay? Now I told you the resistance between base to emitter is R pi, or in other words beta RE. This is resistance in between base to emitter. Correct. So beta is okay. This is the DC gain given over there. Right. RE is V2 divided by IC/DC. V2 divided by VT divided by IC/DC, or VT divided by IE/DC, where VT is 25 millivolt at room temperature. VT is thermal equivalent voltage, right? In semiconductors, VT is 25 millivolt. So now if you'll encounter with this type of circuit, I will just make this and this both are same. If the circuit, this circuit will become like this, so it will be easy to get solve it or get to answer it, right? So I can replace this now. Last time we have seen some circuit, right? In that AC analysis, the R1 and R2 became in parallel combination like this. The capacitor was shorted. This was input resistance RS, and here we had V in. This was the circuit portion. After that, we will encounter with our BJT. Is it okay? And our BJT is given over here. It will come beta RE. This is beta IB portion, right? The current IB is coming into the transistor, and here you will take incoming current into the emitter. Okay, this is emitter part, beta IB. This was the collector part. Between collector to this, RC was connected and load was also connected. This is the entire equivalent circuit of AC analysis if you are doing. Okay, now they will ask in the circuit, in this type of circuit, they will ask find out voltage gain. Find out voltage gain. Voltage gain means this V out divided by V in. So what it means? You have to, solve this circuit from this to this. Then only you can get V naught by V in, or voltage gain. They can ask find out current gain. Find out current gain. Current gain is denoted by AI, and this is denoted by AV. So this will be output current upon input current. The output in the circuit and the input in the circuit. Is it okay? It's like this. So now my main intention was to show this portion. This is the equivalent of BJT circuit. I hope this portion is clear to you. This one. Is it okay? Now we'll take problem. So the circuit is given. This is the gate problem. Gate 1993. It's 3, okay? And the problem is, this is 15 volt connected in this way, 200 kilo, 470, not kilo, okay? This is the emitter part. Current is coming into this, means it's PNP. It's like this. Here connected with 4.7 microfarad. 4.7 microfarad. This is your input stage. You applied V in over here. And here you have 100K also. Perfectly fine. This is the output you are taking over here. This is 6.4 micro. Okay. And you are taking output over here. V output. And this is grounded. Now tell me one thing. Which type of configuration it is? Common collector, common base, or common emitter? See, where are you applying your input? The base portion. Fine. Where are you taking your output? At emitter portion. So definitely it's common. It's common collector. It's common collector. Now the question is, for the amplifier circuit of figure, the transistor has a beta of 800. Beta of 800 given for this, a very large. The mid-band voltage gain V0 by Vi. They're asking voltage gain. Mid-band voltage gain. Mid-band voltage gain, right? And the circuit is given over. You have 4 options for this. A is 0. B is less than 1. C is nearly 1. And D is 800. So friends, if you are getting this type of question, you can solve it without solving it. You can get the answer without solving it. Which type of biasing it is, or which type of configuration it is? This is the common collector. If you remember, in common collector we have seen AV is just nearly equal to the 1. Is it okay or not? So directly I can give the answer. 1 is the answer. But this circuit I'll show by our small signal analysis method. Okay. So first I'll do the DC analysis of this circuit. The DC analysis. In the DC analysis, I'll remove all AC parts as well as the capacitors also. So when you will do the DC analysis of this circuit will be like 15 volt. Here it's a 200K. Here it's 100K. And this is your circuit. Like this. 470. And here is your capacitor. Okay, fine. You can find out voltage drop over here. 100 into 15 divide by 300. So it will be over here 5 volt. 5 volt drop will be here. When you will take the equivalent of this, you will get 1 into 2 divided by 3. So it's 2 divided by 3. So it will be 2 by 3K. Is it okay? It will be 200 by 3K. Is it okay? So if this is 200 by 3K, now you can remove this portion. This portion is not valid now. This portion 15 is connected to the emitter now. Let me draw it again. So this is emitter part. Here it's a 15 volt. Now you need to calculate IC. Why IC? Because you have to replace this by the equivalent circuit. In that I need IC DC. Because I need to calculate beta RE there. Why we are doing this DC analysis? By doing this DC analysis, we can convert the equivalent circuit of transistor or BJT, right? We have seen just now that in the equivalent circuit of the BJT, we need beta RE, that is R pi. Beta is available with us. RE we calculated VT by ICDC. I need ICDC, means the IC collector current in DC operation, right? It is fine. Now, where is the VBE? B to E. Here is the VBE. This is the VBE given over here. You need to calculate this IC. So, I'll apply the input current analysis. So, it will be 15 plus 0.7, 15 plus 0.7 and divide by, wait a minute, let me clear some part and make some space, then I'll show you. Wait. So let's do it like the current I is coming to like this. So 15 plus minus 470 of IE. Perfectly fine. I'm coming to this. I'm getting plus 0.7 volt. And here the current IB is coming like this. Is it okay? So I'm getting positive 200 by 3K into IB. IB is perfectly fine. And at the end I'm getting minus 5 equal to 0. Now I need to calculate IE or ICDC because IE and ICDC both are equal. And definitely in this case they will be equal because beta is very large, that is 800. So what is the relation between beta and IC? IC equal to beta IB. Is it okay? So I beta is IC by beta. IC by beta. I can replace this IB by IC by beta and beta is 800. I can replace this IE by IC also because I need to calculate only IC over here. Let me make some space. Are you getting? So come now. So this 800 and this will go 4 times. So ultimately you are having 15 minus 5 10 minus 470 IC plus 0.7 plus this is 0.7, okay, plus this is 4 and 12 IC by 12. Am I correct? And this is in K actually. Is it okay? Equal to 0. So this is 10.7 470 IC minus IC into 1000 by 12. This is like this. So when you calculate IC, you will get 10.7 divided by 470 minus 1000 by 12. So this will be nearly 83.33. So you will get IC. So it will be nearly IC equal to 26.64 milli. IC is, you have calculated IC. Is it okay? Now let me erase some part. You calculated IC. Remember 26 milliampere. Okay. Now I can remove this circuit. I have to show you now. We will calculate beta RE because the DC analysis is over. Now we'll switch to the AC analysis. Okay. In the AC analysis, we turn off all DC sources, right? And we will solve the circuit. Let me show you the AC analysis now. But before do AC analysis, you need to calculate RE, transistor RE. Is it okay? So RE is, what was the formula? VT divided by IC DC. So RE is VT by IC DC. we know VT is 25 or 26 milli, just near to 26 milli, and IC/DC you have calculated 26 milli, so it's 1. The value of this is 1 ohm. Now you need to calculate beta RE. So beta RE is nothing but 800 into 1, so 800 ohm. Now you can replace this by equivalent resistive network. Now I'll do the AC analysis for this. Okay. So to start with the AC analysis, why I'm going to do the AC analysis? Because I have to calculate V0 by Vi, and this V0 is the AC, this V in is also AC. That's why, right? So the equivalent circuit of this is, I'm drawing the equivalent circuit for this first. The equivalent circuit of this is beta RE, that is 800 ohm, perfectly fine. The current IB is coming like this. Okay. This is the emitter, and the emitter is looking like 470. This is the 470, and this directly grounded. Here at 470 I'm taking V0. This is the collector portion, directly grounded, but the current is incoming from the emitter. Current is incoming. See, this IB will be outgoing. And what about IC? This will also beta IB times will go outside from the circuit. This is the circuit this is the equivalent circuit of the transistor, but you have to do this circuit parameters also. This will be 200k in parallel with 100k like this. Okay, and they are grounded because the DC portion is grounded. So this 200 in between this point and ground. So 200 in between this point and ground. 100k between this point and ground, this point and ground. And over here you have V in. This is your equivalent circuit. Now we are taking output over here also. Okay. So you have to calculate V0. Let's change the direction, because I need to calculate, or I need to show IB plus IC is IE only. So this is like this. This plus this will be IE. When current will be over here, I'll take it V output. Okay. So how to proceed now? We don't know IB. We know the beta. It will be 800 of IB. Is it okay? Again, we can resolve this if we want. 100k and 200k, they are in series. So, they are in parallel. 200k divide by 300k, k got cancel, 0. This is 200 by 3k. So the equivalent of this you can replace now by only one. Let me do it clearly. This is 200 by 3k. Okay, 200 by 3k. Let me do it. Wait. Here the current is IB, and here the current is 800 IB. Is it okay? Now this IB is current coming to IC. Here 800 IB current is coming to over here. So here the total current coming is 801 of IB. Is it okay? So if you calculate V0, wait. So for this circuit, V0 will be, tell me, V0 will be 470 multiply with 801 of IB, 801 of IB. Is it okay or not? Is it correct? Now you have to divide it by IB only. So but you are calculating for what? you are looking for voltage gain, that is AV. AV is V naught by V in. Is it okay? So V naught portion is over. Let me write over here. V naught is 470,801 of IB. Now I need to calculate V in. How to calculate V in now? Tell me. To calculate V in, you will apply the KVL in the input side of loop or mesh, whatever. Means you will start from V in, you will go to the ground. Always start from the V in and go to the ground if you want your current or your voltage drop or whatever it is. So let me show it over here. So V in, I am starting with V in, perfectly fine. You are going into this, you are having drop 800 IB. You are going into this, here you are getting minus 470 and your current is 801 IB. This is your current equal to 0. Starting from E in and going to the ground, you are encountered with this two terms. So finally your V in will be, if you will calculate V in, it will be 800 plus 470 into 801 of IB, like this. Is it okay? Now with respect to this 800 is very less. 800 470 times, and this is only one time. This is very less amount. So your V in is nearly 470 into 801 of IB. Means your gain is, this is your V naught, 470 into 801 of IB, and this is your V in, 470 into 801 of IB. So they will cancel out. AV is equal to 1, but this is not exact equal to 1, this is nearly equal to 1. Okay. So this is the question based on the common collector. Earlier we identify what is the answer, that is 1, because this is the voltage buffer. Okay. Now this is the procedure to solve small signal analysis. First the DC part and then AC part. We'll take some more problems. So let's take another problem, and this is the GATE problem, 2008 problem, right? GATE 2008, and this is 2 marks problem. Actually this is the statement linked question, so total marks are 4. Means 2 marks, 2 marks, 2 questions. And the circuit is given over here is, let me draw the circuit within 30 seconds. I'll try to draw it. 20k, 10k. This is 10k, 20k, 3k, ammeter. Ammeter is connected with 2.3k in parallel with capacitor. So obviously this will be common ammeter, right? Here it's connected with C2 coupling capacitor, and here connected with 3k, like this, taking output 3k, 20k, applied with 9 volt VCC. This is the input. Input capacitor, and here applied with, I'm sorry for this, V in. Okay, this is the circuit. This is the entire circuit given over here. This is the small in which we have to do the small signal analysis, because DC and AC part both are given over here. And the question, 2 questions, but before that some conditions are given. The following transistor circuit VB equal to 0.7. The voltage drop is given over here between base and ammeter. 0.7 given over here. RE is given 25 millivolt divided by IE. They have given RE in this format. And beta and all the capacitors are very large. Beta is very large. These things are given in the question. Now, the first part of the question is the value of DC current. The value of DC current gain. DC current gain. They're asking the value of DC current IE is, sorry. They're asking the value of DC current I. DC current IE, the first question is. And you have 4 options for this. 1 milliampere, 2 milliampere, 5 or 10. So first I'll solve this part. This is the DC current, means definitely this type of question we have to start with the DC analysis only. Is it okay? So let me start with the DC analysis. When you will do DC analysis, all AC part of the circuit will be turned off. All capacitor of the circuit will be open. Okay. So let me do the DC analysis for this. DC analysis. This is 20K, 3K connected with 9 volt. The circuit is like 2.3K over here. The capacitor is gone from the circuit. This is the circuit. This is 10K. Is it okay? And this over here you have V0. And apart from this is gone. So the 3K is useless. Right. Now here is the IE. This is IE is nothing but IE DC, whatever they are asking. So again this is the potential divider. Again you can find the potential over here. So this will be 3 volt. This will be 3 volt over here, and the equivalent of these two will be 20 into 10 divided by 30. 20 into 10 divided by 30. It will be 20 by 3K. So this will be 20 by 3K. Now you can remove this part. This is the input equivalent, right? Perfectly fine. Now 9 volts will be connected already with this. Here it is 3K. This is your circuit. Let me make it clear, this portion. So this portion is like this, 20 by 3K. Whatever this combination is there, now I took the equivalent of this. 3 volt, the voltage across 10 volt, 10K. 9 into 10K divided by 30K, it will be 3 volt. This is your circuit. Now the question is, we have to calculate IB and we have to consider this portion 0.7 they have given in the question. So proceed. So okay, let me erase some part. It's unnecessarily problem. Wait a minute. So 3 volt minus 20 by 3K of IB. This is IB minus 0.7. Minus 0.7. And here you are getting 2.3K of IE equal to 0. Equal to 0. Is it clear to you? Now remember, in the question they have given IB is very large. So sorry, beta is very large. When beta is very large, IB is nearly equal to 0. So I can remove this IB from the circuit. So you will be remained with, this is the 0. 3 minus 0.7, it will be 2.3, and it will be 2.3K of IE. So IE is nothing but 1 milliampere. So first portion answer is 1 milliampere. This is very easy 2 marks question. Now in the second one, they're asking, let me erase it first. This is the first portion. They're asking for the DC current IE. We calculated IE. And one more thing, please remember always, when beta is very large, the base current will be 0 in the circuit. When base current is 0 in the circuit, IE will be equal to IC in the transistor, right? So first portion is over and we got 1 milliampere IE, and that is DC, correct? Now it's time to do the AC analysis for this circuit. Let me make it clear. I will do the AC analysis. The DC is over. And the second question is actually, let me write the question first, then we will do the AC analysis. For that question we need an AC analysis. The mid-band voltage gain of the amplifier is approximately, they're asking voltage gain. They are asking voltage gain, and voltage gain is nothing but V0 by Vi. So V0 is AC, Vi is AC, so we need AC analysis of this. So to switch into the AC analysis, you should be knowing, or you should have knowledge, equivalent circuit of transistor. The transistor equivalent circuit will be beta Re, and here you will take like this, and so you need Re. Re is given over here 25 milli divided by IE. IE is 1 milli, so this is 25. This is 25. Now you don't have beta in your hand, so what you will do? So we'll keep beta as it is. Okay. Now let me draw the AC equivalent circuit. The AC equivalent circuit. Re is 25 ohm we have calculated. Now let me draw the entire AC circuit. So now V in will come into the picture. This DC source will be grounded. The capacitor will be short. The capacitor will be short. So this is grounded. So in between this point, if this is base point over here, so between this base point B and ground, you are having 20K as well as 10K. So I'm drawing the equivalent. 20 by 3K. 20 by 3K is over. Across B point, V in is applied. V in is applied. Perfectly fine. Here, this is the transistor territory. In the transistor territory, you are getting beta Re, where Re is 25 calculated. Over here, this is the emitter, and that emitter is grounded. See, this is grounded, right? Because you shorted the capacitor. So emitter is grounded. Now come to the collector one, and in the collector one, this is beta IB. The collector itself having two resistances. One is from point C to ground 3K, one is point C to ground 3K. So you can resolve them and it will be 1.5K. And here your V0, you have to calculate your V0 over here. Okay. Now this is your IB, friends. This is your IB, friends. You need to calculate AV. AV is nothing but V0 by V in. So first calculate what is V0. The V0 is C. This is the closed circuit. This is the closed circuit. This current will not come to this portion. It will go into this. So this IB current is coming from downwards and dropping itself into 1.5K. So V0, the polarity of V0 we are calculating it this way. So V0 will be definitely negative, and it will be beta IB into 1.5K. Perfectly fine. This equation is okay. Now we'll divide by VI. What is VI? Again, we'll start with VI, we'll go to the ground. Okay. So VI over here, VI minus IB into this, IB into beta into 25, and this is ground. Everything is over. So this is equivalent to this. So you are getting this beta IB into 25. So beta IB and this is IB will cancel out. So it will remain with minus 1.5K divided by 25. Okay. So when you will divide it, you are getting minus 60. So your voltage gain is minus 60. Is it okay or not? So this is the common emitter. In the common emitter, the gain is 180 degree phase shifted. So it's a true. By the way, the 4 option we are getting, and in all 4 option I'm getting minus, minus, minus and minus. So option D is correct for this. Is it okay? So let's take another problem. It's also very interesting problem, and this is GATE 2012 problem. Okay, and 1 marks problem. This is 1 mark problem, and the problem is the equivalent circuit is drawn of transistor. This is R pi, we have seen, right? This is collector, this is collector, this is base, and into the collector R0 is also connected with this current source, like this, and it's like this. Okay, R pi 3CB, and here the current is IB. And the question is, the current IB through the base of a silicon NPN transistor, the IB is given 1 plus 0.1 cos 10 to the power 4 pi t milliampere at 300 K. 300, this is the room temperature. The R pi in the small signal model of the transistor is, then R pi is, and your options are 250 ohm, option B is 27.5, option C is 25 itself, and option D is 22.5 ohm. The R pi. Is it okay? So R pi is what? So R pi, we have seen this is nothing but beta Re. You need to calculate Re, and Re is Vt divided by IC DC. Is it okay? So what is Vt, friend? At room temperature 300 K is given. The Vt is 25 milli. What is IC/DC? Can I write this IC/DC is beta IB DC? Can I write it? Yes, I can write it. What is the IB DC? What is the DC? Remove the AC part. The DC is only 1. So this is 1 only, given in milli. So this is 25 milli. Milli will cancel out, divide by beta. Re is 25 by beta. Just place the value over here. Beta into 25 by R. 25 by beta. Beta will cancel out. You are having 25. Option C is correct. You are getting 1 marks. Okay. So let's come to the next problem, and this is GATE 2014. GATE 2014 and 2 marks. Okay, and the problem given is, I'll take 45 seconds. 12 volt 33K, 11K grounded, 5K, 10 ohm only. This is RS given. This is RE given. 1K. And RE in parallel with capacitor. This is grounded. Okay. And over here I have 1 microfarad. And this is V in. I'm applying over here. And over here I'm taking output. This is 1 microfarad given. This is your question. 33, 5K, 10. This is ohm. Okay, here the student make mistakes over here only. They'll write it 10K and everything will be spoiled. Okay. Here the value is 1 millifarad. Now the question is, I'll read the question. For the amplifier shown in the figure, the BJT parameters are VB 0.7 always, 0.7, beta is 200, thermal voltage VT is 25 milli. The voltage gain V0 by Vi of the amplifier is, it's this fill up type. In the volt they are asking. Right? Now, definitely we have to do the AC and DC analysis. This is a small signal analysis type of circuit. So first I'll do the DC analysis for this circuit. Okay, let me change pen. Is it like this? DC analysis. I'm going to do the DC analysis, DC part of this. So the DC part is 12 volt as it is, 30k, 5k, 11k, like this, and this is here 10 ohm, and this portion remaining RE will be grounded because we are making it okay. It will be also reflect over here because you are making capacitor of open circuit. RE will be there in the circuit. It is 1k. Everything is fine. The capacitor is removed. Everything is removed. This is the circuit. Okay. Now to this circuit we can resolve this portion again. Here the voltage will be this will be 3 volt, I think, right? 3 and 4. So this will be 3 volt. And the equivalent of this to 11 and 30k is 11 33 divided by 44. 11 4 33 by 4k. 33 by 4k. Now I can remove the remaining part because I made it equivalent. I can remove this 11k. This is my input circuit now. My input circuit is 3V. This is 33 divided by 4k, and this is 12 volt over here now. This is grounded. Okay. I need to calculate IE or IC. Here beta is also given. I'll apply the input in input mesh, the KVL. So 3 minus 33 by 4k of IB minus 0.7, and here I am having 10 and this 1k. So this 10 of IE, 10 of IE is equal to 0. Is it correct? So this IE I can write IC, no problem at all. This IB I can write IC divided by beta. So IC divided by beta is 200. So IC is unknown in the circuit now. So this is 2.3 equal to 33k by 4 plus 1010 IC. 1010 IC. And this is divided by 200 also. And this is 2.3. So overall 33 into 5 divided by 4 plus 1010 of IC, and this is 2.3. Correct. Let me erase some part, then I'll solve it. So this is 2.3 into 4 divided by 33 into 5 plus this is 4040. This will be your IC. When you will solve this, you will get, so you'll get IC equal to 2.2 milliampere. 2.2 milliampere. So IC part is over. So now RE is VT divided by this. VT is 25 milli divided by 2.2 milli. So it will be milli will cancel out. It will be nearly 10 point and something. Is it okay? Actually it will be 11.23 ohm. So this is your RE. If this is RE, what is beta RE? You will multiply this quantity with 200. Okay. Wait a minute. 11.23 multiply with 200. So it will be 5.4k. I'm sorry, it will be 2.2K. Is it okay? So this portion is over. You calculated beta RE. Now we'll put the values into the AC signal, AC analysis. Okay. Let me erase it. Now the DC part or DC analysis over. Now we have to calculate voltage gain. That is the AC voltage gain. That's why we have to do the AC analysis for this circuit. I hope the concepts are pretty clear to you now, right? So let me do it. Now the AC analysis for this. The AC analysis need beta RE. We calculated it 2.2K. The AC analysis will make it short, so this part will be over. Here it will be 10 ohm only. This will be connected with beta IB. This is beta IB, the collector, and the collector is connected with 5K up to ground. So this is 5K. Here I'm taking V0. This is the input part. The input is 33K and 11K. They are also connected up to the ground, and equivalent is this is 33 by 4K, and here we are applying V in. Is it okay to you? In this circuit the current is IB. Now you need to calculate V0 by VI. This is your voltage gain. What is V0? Calculate it. This is grounded. So your V0 is this current into 5K. So beta IB into 5K, but sign is negative because the polarity of V0 is like this, but actual voltage of polarity is opposite to original one. Is it okay? So this is V0. Come to the V in. For V in, simply procedure, have to start from this point and you have to go to ground. So V in is nothing but 2.2K of IB plus this 10 into this beta, and this is 200 IB. This is like this. So it is kind of 2.2K plus this is 2K IB. So it is 4.2K IB. This is V in. This is V in. Now the voltage gain is minus beta IB into 5K minus beta IB into 5K divided by 4.2K of IB. IB will get cancelled, KK will get cancelled. So finally its AV is minus beta 5 divided by 4.2. Put the value of beta. Finally you are getting minus 238. This is the voltage gain for this circuit. So I hope the concepts are pretty clear to you. In the next module, we'll see some more problems based on this AC and DC analysis. Okay. So again, I'm telling you how to proceed it. First, you need to analyze the DC part of the question. In the DC part, what will become at output? You will get RE from the circuit because you need beta RE to replace this BJT as the equivalent resistive circuit. This RE will come because of DC analysis only, because RE is nothing but VT divided by IC DC. So to calculate RE, you need the value of IC DC. So for the IC DC, you will do the DC analysis of the circuit. After doing this, you will be available with RE. Now you will replace this entire BJT circuit with the equivalent model. And equivalent model we have seen it. This portion will be beta RE. If this is emitter, this is base. In the base the current is IB. In the collector the current is beta times of IB. And this is your emitter. Is it okay? So this is the equivalent part of the BJT only. Now we are having the circuit elements also. In the AC analysis, the DC part will be 0, means grounded. So if you will ground this part, so base to ground, you will have 33K, you will have 11K, 11K. They are in parallel. So I resolved it and took over here 33 by 4K. At this portion, the capacitor will be short and the voltage is V in. At the output stage, from collector to ground, you have 5K. This is collector to ground, you have 5K, and collector is directly connected to V node. So this is V node. Is it okay? So this is the procedure. So I hope it's clear to you. So we'll meet in the next. Till then, take care and bye.